Hey everybody, it's Rex, back at it with more math questions from the Red Book. So, I'm in test 3, problem number 55. First of all, pause the video, read this question, and then press play when you're ready to go. Okay, so what we're doing here, again, is we're just being tested on how well do we know rules about exponents. How well do we know how to deal with exponents? So if this is something you have never seen a problem with a variable in the exponent before, you've never done this in math class, I would skip it first while you're studying and work on things you have already learned. Perfect those before you go teach yourself something new. But if you've worked on this in class, let me give you a little bit of a reminder on how we're going to deal with these variables in the exponent. You ready? Not that tough if you know what you're doing. But if it's a little confusing or you did not review this, definitely skip it and try it again during the work portion, not the survey at the beginning of the test. So the first thing I'm going to do is, I would really like to only have these terms up here and no base for either of them. So I'm going to try to give them both the same base. It's pretty easy though, because 3 and 9 are not that far off. So I'm going to keep this side the same as 3x to the x plus 1. Also, I'm going to turn 9 into 3 to the second, and that has to be multiplied with the exponent that was already there. Let's simplify this out. 3x plus 1 equals 3 2x minus 4. Now, what's important to know is if we have the exact same base, we can then essentially discount the base entirely and only deal with our terms left in the exponents. Awesome. So what I'm going to do is I'm going to subtract x from both sides. So I will end up with 1. Don't need that there. End up with 1 equals x minus 4. Then add 4 to both sides, and I will end up with x equals 5. Now, we have to ask, what were they asking for? The question is very specific this time. We are reviewing exponent rules, but at the beginning of the whole question, they were asking us, how many values are true for x? Maybe this original equation was undefined. No real number works for it. Maybe 2 or 3 numbers work for it. Maybe it ends up being a trinomial and there's 2 possible answers. But it doesn't. It simplifies to a single answer. So how many integers can be represented by x? The answer is only 1. 1 integer can be represented. And that is letter answer B. Great job.